Typical gas turbine engine. The learning objectives describe what you will be able to do after you complete this lesson. You will explain the physical laws affecting gas turbine performance, explain the relationship between the atmosphere, air, and gas turbine operation, explain the Brayton cycle. Basic single compressor gas turbine. All gas turbines are different types of the same basic single compressor gas turbine. To better understand gas turbine the operation, several basic physical laws must first be explained. These physical laws explain the actions of the compressed air, the burning gases and the forces created from burning the fuel and air mixture. These laws are Newton's laws of motion, laws of thermodynamics, Boyle's law, Charles's law. Newton's first law: a body at rest will remain at rest unless it is aided on by an outside foroid. Newton's first law explains why a force is needed to make the gas turbine work. In the figure, a ball on a level table will not move until it is made to move by some force such as the wind or pushing it by hand. Similarly, until the fuel and air the mixture is burned in the gas turbine, there is no force for the turbine to use to turn the rotor shaft. Newton's second law explains why the air must be compressed and accelerated to create a force. In the figure, a hammer is used to drive a nail. The force of hitting the nail is proportional to the mass weight of the hammer multiplied by the velocity of the hammer when it hits the nail. If you also use a heavier hammer, it is even easier to drive the nail into the wood. Mass and acceleration directly affect the amount of force created. The more compressed air mass that enters the gas turbine, the more the force created from the combustion process. To every action, there is always an equal and opposite reaction. Newton's third law explains how the act of creating a thrust force results in the reaction of the turbine rotating. In the figure, a boat is near the bank of a river. The person steps from the boat toward the land. As his body pushes forward, the boat is pushed backward with the same amount of force. In the gas turbine, the thrust force is the action. This force is directed into the rear of the case and onto the turbine blades. The blades of the turbine react to the force and turn the rotor. Laws of thermodynamics. 1. Energy cannot be created or destroyed. Energy can only be converted from one form to another. 2. Heat cannot be transferred from a colder body to a warmer body. Heat is transferred from a hot body to a cold body. The volume of a confined body of gas varies inversely with its pressure, as long as the temperature does not change. Gas under normal gas under double the pressure at normal pressure at half the volume original volume. Compressed air improves gas turbine performance. Compressibility is an important factor in gas turbine performance. Gas turbines use compressed air for combustion. Boyle's law can be explained by placing a quantity of gas in a cylinder that has a tightly fitted piston. When a force is applied to the piston, the gas is compressed to a smaller volume. When the force is doubled, the gas is compressed to half its original volume. Charles's law explains the expansion of gases when the heat is added by burning fuel in an engine. Charles' law is explained using the figure. The first container holds a certain volume of air. If the air in the container is heated, it expands and its pressure increases. The expanding air pushes against the container. The higher the temperature, the greater the force applied by the expanding volume of air. In the gas turbine, the forces created by the hot, expanding gases push against the blades of the turbine and turn the rotor. Atmospheric factors affect the performance of gas turbines. Some of these factors are air density, contaminants. Temperature and water content affect the density of the air. Because cold air is denser than hot air, it has more mass. The more air in the gas turbine, the more force created. On a very cold day, a gas turbine can exceed its peak load. On a very hot day, a gas turbine will produce much less power. The atmosphere also contains foreign matter that is harmful to gas turbines, such as pollen and dust. The contaminants reduce the efficiency of the turbine and damage internal parts. The Brayton cycle defines what takes place in the gas turbine engine. These events are controlled by the physical laws described on the previous pages. The events in the Brayton cycle take place in specific sections of the gas turbine. These events are compression, combustion, expansion. Exhaust. The Brayton cycle is unique among engine cycles because all the events in the cycle take place at the same time without interruption. The exhaust event is the only part of the cycle that does not take place in the engine. Summary. Several physical laws are at work when a gas turbine is operating. Turbine, Newton's laws of motion RO 105 laws of thermodynamics, Boyle's law, Charles's law, atmospheric factors such as air L density and contaminants will affect gas turbine engine performance. Understanding how and why a gas turbine engine works is important to safe and efficient operation.